Okay, right now we will learn a little bit about the introduction of Python. You can start to, this is not generated, you just want to generate, example, click to audit. So basically you want to import the content from the drive, which you permit the same thing, you connect. And of course I use this Google account, continue. And then yeah, it will be somehow linked. The first one is each Python object has three characters: object type, the object value, the object identity. Yeah, so I can run content and Google Drive in my drive. Yeah, so basically is this drive, my drive, and yeah. So most popular Python object have either data or function in both associated to them. These are called attributes. So you import the math, and then math pi is a pi. So pi is equals to the math dot pi. Then you print pi to a power of 2, and then pi. So pi to a power of 2, so it's like 3.14, right? Where is pi, and pi times 2, sorry, pi times 2 is 6.2. So if you look at power, you can actually add a power here, and let's try to run. And then the power of pi would be about 9.8. Yeah, so you can also do a math square root of 20, or where you will give you about 4 square root of 25. Yeah, when you have a square root of 25, can give you 5. Now we import numpy as np, np which is numpy square of 10. Then you can actually also run this. Square of 10 is 3 point something. Let's try to run 4 times 4 is 16, right? Yeah, so square root of 16 will be 4. We can run that, it becomes 4.1. So basic operations are add, multiply, divide, not equals, 2 equal is equal, random choice, and assignment. Assignment is not a mathematical operation, so let's try to import random, and the random choice are 20, 50, 80, and 257, right? So you import, then you actually random. So when you run, just now is 20, then you run again, this becomes a random choice. Yeah, so out of this you can be random. Expression and boolean. Expression is a combination of object and operating that computes the value. Objects of boolean type have only two values, true or false. Boolean operation is or and not. Yeah, so type false, when you run this, it becomes a bool, which is a boolean. True and true, right, is a double equal sign, that means it becomes a true. Sequence is sequentials are object that form in them in sequence. Three types of sequence are list, triplets, yeah, triple range object. S is equals to 4, 8, 11, 15, 21, 25, and 8, and then you have first row, and then 6, right? 6 in a column, so you can run. Basically, you still first row, right? 1, 2, 3, 4. All these numbers becomes a first row, right? And 6, 0, 1, 2, 3, 4, 5, 6. So you see 28 is missing. So let's say I run this at 5 and at 5. Yeah, so 0, 1, 2, 3, 4. You end at 5. Yeah. So what is 0? 0 becomes 4, the first column. Minus 1 is from the at the end, right? So at the end is 28. Yeah. So minus 0, 0 is nothing much but open. And then you have run 4, 8. And then minus 0, the last digit, and then 2, which is 0, 1, 2. Right. So it becomes 4 and 8. So lists are mutable objects that are sequence of object of any type to be stored homogeneously item. String are sequential individual where lists are sequential of any Python object. Lists can be mutable but strings are immutable. Lists of strings are with their own methods. Odd rows equals to 1, 3, 5, 7. Odd numbers equals to 0. Let's try. So 0 is the first one. And then let's say we try 3. So 0, 1, 2, 3. Run. It should give us 7. Right? The odd number 1, 3, 5, 7. Odd number append, you add this to the last row, you append, and then we can see you get actually 9. Let's try to append, I don't know, maybe 10 or 11, right? Run again. You cannot do that, yeah, because then so it must be exactly argument. So even you run that, so I need to remove this. So even if you run odd plus even, it will give you odd plus even. Then you can sort the numbers. So numbers which just now we assign numbers, right? Then you sort 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can actually sort. Numbers sort in reverse equals to true. Then you reverse, becomes 9, 8, 7, 6, 5, 4, 3, 2, 1. So number dot reverse can be also reversed in this way. So range are immutable sequence of integer which they use for their loops. A range require less memories, and a range can be followed in the number. So you have a range of 8, right? So 0, 8, range of 5, 0 to 5, and range of bracket 5, it has a 0, 1, 2, 3, 4, 5. Yeah, so this is how you do. So this is a string. String is immutable, that means you cannot change. And then if you run this, see ship type 1 type 2 3 4 5. Length is just ship type, so when you print out it's 5. Yeah, let's try one more. Say maybe you have a special ship, right? And then you run it, so it should give you 6. Yeah, ship type 0, the first one, which will give you container ship, and let's say I change to 3 or 4, which will give you 1, 2, 3, 0, 1, 2, 3, 4. There's a passenger ship. So if you run 0, 3 container ship bulk carrier, so 3, right? 0, 1, 2, stop at 3. Yeah, so minus 3, let's try this. So minus 3, 1, 2, 3, minus 3 is a row. Special service strip, if you run is false, that means you don't have this. But we can change to say I want to check row ferries. Yeah, so row underscore ferries. Let's try. Ship type, there is something. So because maybe we put in row under ferries, then you don't have. Yeah. So sets are unordered collection of distinct hashable object. It can be used for immutable objects like numbers, strings, but are immutable objects like list and dictionary. Cannot be accessed. Element in the sets can be duplicated. So you run the integer sets equals to set is equals to like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 13. The length, you count the number of length which is immutable. So you run. How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So there's 10. Yeah. In the int is basically the sets, integer sets. You add 10 to it. Add the last one to it, so it has 10 and 31. You kind of add this. Let me try to add maybe 11. See whether you can add this way. Now you cannot add by this way, so it becomes that it's not possible to add this. So we have to take out, say, let's say I take out the 10. then you can run smoothly. Let's say I put 310, right? Then it becomes at behind, right? So you just add the numbers in. Okay, so map key dictionary is basically the key objects to the value objects consists of keys, value pairs where the keys must be immutable of the object and is mutable. Is mutable, therefore its content is modified once you create the dictionary on the fly. Can be used for very fast lookup for n order data. Yeah, where is it? N order data. Yeah. Yeah. So let me just, okay, so it's not a sequence. Let's run this. Year build, parentheses, then you have your basically your libraries in, right, your dictionaries, and then year build. Then you put Seabird. You want to check Seabird 1990s. So the key is like dot keys. The back is actually that. So you can actually see this. So let's try to, instead of Seabirds, we cut this should be 1944, right? So we can change this. Then we run. Should be 1994. For ship name in the year build dot key, and then you print the ship name, year book, and ship. So see, you print ship name, year build, right? And you parentheses the ship name. It goes to the next line, and then that's how it shows in this format. So let's try to run again. It will come out this way. Then current year is 2020. So you try to write some codes for ship name in the year build dot key. So key is basically the value. Ship age is equal to current year, right? 2020 minus ship build. So you print the ship name, ship build, and then the ship age. When you run this, Seabirds 1990 is 30 years old, right? You print a ship year and ship age. Now let's change the current year to 2024. When you run, it actually should be 34 here, right? Yeah, adding another 4 years old. Yeah. So current year is 2020, right? And then let's change to 2024. Ship name in sorted years, then you actually become, you sort it out, right? So you run this, you sort in the year build. You still print your ship minus the current year, and then that's how it's sorted. So ship age is current year minus ship age, and maybe I can put in like +1, right? Then see, 29 become 30. Yeah. Statement is used to compute values and assign values to modify attributes. Statement is also a return statement is used to return the value from a function. Pass statement has nothing to do, but is intentionally kind of blocked. So if statement and else statement. So we have x equals to 5, y equals to 7. If x is greater than y, then absolute value becomes x minus y. If y is greater than x, your absolute value becomes y minus x. Else, absolute value equals 0. So let's try. So in this case, y is greater than x. Y is greater than x. Then y minus x, that means 7 minus 5, it becomes 2. Then you print absolute value, right? So let's change this to say 17. Yeah? 17 minus 5 will give you 12. So this is how it is done. For loop is a sequence of iteration that assign in a sequence to target at least one time and run the block code for them. Unless the loop is terminated early without the break statement, the block of the code is run as many times as it are an item in the sequence. So for ship name in year dot key, you open parentheses. That's how you can actually write it, and then you print out as a name, right? And let's run this. Yeah, so this is it, and you print. Use elimination alphas. You put in the alphas, and let's try. File is Python input different lines. alpha. So there's some indentation error. Not sure what happened. Let's skip this. So emulator is a function that returns to an emulated object with is an iterator. Each element is accessed with the emulator object a tuple is returned, which contains the index element for the index and element. So it's kind of like a real number. With each iteration for loop, it assigns the element of this return tuple to the index element variables. For alpha in emulate, right? Emulate, now we learn about alphas, and then you print out the count. So let's try to find. Something is not right. SubPython base in line 6 is wrong. So use similar alpha is comma 0.1. Okay. 3 zeros. Let's try to run. In line 4 print alpha. Expected indented for statement. Okay, take out for alphas in alpha. Error. So you can print say plus. Something is not right. Not sure exactly what happened. Okay. Still some intention error. Let's look at the error. So in the expected value, line 5, use emulate, use alphas in alpha print. So alternative, you can use the emulate code in iteration covers. You print alpha. Okay, for I, comma alpha in emulates alpha, and then you put alpha I. Okay, let's try this code, right? Then you print the alpha 0, 1, 2, right? So that's one way to look at it. So you count alphas. So I've changed this to alphas, right? The float is not a trouble. Okay. So let's see. Colab AI could actually help you to think. See what it comes up with. Run the code, convert alpha to at least. Okay, print types of alphas. So you want to print for alpha in emulate. So let's see what we can use. Print alpha. Okay, let's try this code. Copy, and then let's try. Yeah. Right. Something is wrong. Each iteration of loops. So this is emulation is somehow very funny. Okay. So for alpha in emulative alpha, let's see. It's a float object for alpha in okay. What is wrong? Let's try it. You count alphas. For alphas and alphas, emulate alphas, print count, first bracket. Not sure what happened. It's not running. Let's try again. For iteration tools, you need to import, but I actually did import. Let's try this again. Let me try one more time. Yeah. Okay, don't know. Let's jump this. So comprehensive reason, very fast, very elegant. You double click. Number equals to range. Let's try it. So number equals to the range of 10 square. So 0, 1, 2, 3 square, 4, 5, 6, 7, 8, 9. So 10 don't have, so you actually can do that. Use a comprehensive square. So basically still the same. You can use a square too. Now you sum I and I for the range of 4. Equals to 14. You sum your I range. So if you don't sum your in the range of 4, I equals the range of 4. Let's try I equals range of 2. What will you get? Get 1. So 2, 0, 1, 2. Right. And then we have 4. 14. 0, 1, 4, 5 plus 9 equals to 14. So let's try plus range of 5. So it's 14 plus 16 gives you 30. Yeah. So it's using what do you call that? Let's try to do this. Using sum from 0 to 5. Yeah. So functions are used as a definition statement. The results are sent back to the caller for the return statement. So define addition x, y, x, y, sum x plus y, return sum. Then you sum, you add 10, 20. So you print sum is this. So x plus y, right, is your sum. So let's try to change this to say 25. So basically it is a sum. You add up. Yeah. So this is basically a function. Define, add and subtract. Sum is x plus y, difference is x minus y, return sum, comma difference. So you assign the functions the sum and difference. You add and subtract 10, 11, you print the sum is this sum. And we can think, yeah, sum, add and subtract. So you add in, add is this, subtract is x minus y. So this is a function of how you can display. So function to calculate shift power, you have a list of numbers. You import matplot inline, import math, import numpy as MP, import a netplot, right? So you plot this first. Code, you have all the shift, and then you define kvst in t. So you have r1 equals to a certain function. Then you have now equals to 0 for I in range of 7, 1, 2, 0, 1, 2, 3, 4, 5, 6 before 7. Then you have t to a power of I. Then now is equals to m plus p. Then you run your my equals divide by 10 and return. Then you actually have max, and yeah, this is basically the results. You can have that results like unresistant friction the speed, the kinetics velocity, which is basically you print what is required. Kinetic velocity is from nothing of any all the rows to .10f format. Then you print a minimum speed. This is a minimum speed. Pseudo minimum speed displacement sheet. This is the formula, and maximum speed is this, photo speed is this. So this speed becomes plus minus, yeah, total resistance. And then you calculate the speeds in knots, total resistance, you print. How you calculate, basically you calculate, yeah, x equals to b, and then you plot blue with a ring or with a circle, or green with a S. So green with S is square, blue is, yeah, so you can plot the line. So this is one of the way to write that. Yeah, so this is how we can use Python to kind of write some codes.